Welcome back, Cubs. In this video, we're going to review a limiting reactant practice problem found on page 299 of your textbook. Let's take a look at number 2. So it says carbon reacts with steam at high temperatures to produce hydrogen and carbon monoxide. So for these problems, remember you want to make sure you have a balanced chemical equation. We went from word to chemical formula in our equation. So here we have our balanced chemical equation. Cool. So A says if we have 2.40 moles of carbon and we expose that to 3.10 moles of steam, identify the limiting reactant. So just a reminder, to determine if you have a limiting reactant problem, if you have two reactants that are your givens, then you know that you have a limiting reactant problem. So the first step, what we want to do is convert from moles of carbon to one of the products. It doesn't matter which product as long as you choose the same product for both of these conversions here. So let's just go with the first one, H2. So mole over mole, use the balanced chemical equation and utilize those coefficients. So we have a 1 and a 1. So we have 2.40 moles of hydrogen. So what this equation is telling us that if all of this carbon reacted, we would end up with 2.40 moles of hydrogen gas. We're going to do the same thing for the other reactant that's given. Remember, the starting unit in the numerator is going to drop down to the denominator. Now we need to convert to one of the products to see how much product could be produced. Make sure you're using the same product here. Mole over mole, refer to the balanced chemical equation, use the coefficients, 1 and 1, and we have 3.10 moles of H2 produced. So what the second equation is telling us is how much hydrogen could be produced if all of this water reacted. However, these two reactants are present in our equation. One of these is going to be used up. When it's used up, the reaction stops. So we look at which one makes the smaller value of product. The smaller value indicates our limiting reactant. So that will be our limiting reactant. Since this is our limiting reactant, carbon, that means water will be our excess. Okay, 2b says how many moles of each product would be formed. So for 2b, we need to start with our limiting reactant, 2.40 moles of carbon. We want to know how many moles of each product would be formed. So we're going to go to moles of hydrogen from moles of carbon. We get 2.40 moles of hydrogen. And then 2.40 moles of carbon, starting with our limiting reactant again. This unit drops down. Our other product is carbon monoxide. It's a 1-to-1 ratio based on the coefficients from the balanced chemical equation. And we have 2.40 moles of carbon monoxide. So 2 products, 2 answers. Then 2C is saying what mass of each product would be formed. So here we have 2.40 moles of H2. It's just asking us to convert this to grams of H2. When gram and mole are together, mole gets the 1. Add up the parts from the periodic table. Do your arithmetic, and we get 4.85 grams of hydrogen produced. But it wants both products, so now we have this value here, 2.40 moles of CO. This unit drops down. Add up the parts from the periodic table. 28.01 grams of CO. we end up with 67.2 grams of carbon monoxide produced. 2 products, 2 answers. So that's walking through page 299, number 2, limiting reactant practice. Let me know if you have any questions. Have a great day, Cubs.